Hello students. So the next instruction of data transfer group that I'm going to discuss is MOVM, RS. So I have told you every time in all the instructions that I'm going to use or I'm going to teach you in 8085 microprocessor, the representation RS will represent source register, RD will represent destination register, and M will represent memory location, which is specified by the content of HL register pair. Okay, so the instruction, just coming back to the instruction MOVM, RS. So what does this instruction do? This instruction copies the content from source register to the memory location mentioned. For example, MOV, okay, here I have not written. Okay, let's take an example. MOVM, let's say B. MOVM, B. So what does this instruction do? It will copy the content of register B into the memory location, which is specified by the content of HL register pair. Suppose at that time the content of HL register pair is 7030H. So after exit, the content of register B is 40H. Before the execution, again I am repeating, before the execution of this instruction, let us suppose the content of register B is 40H and the content of HL register pair is 7030H. Now after the execution of this instruction, what will happen? The content of register B will get stored into the memory location, which is specified by the HL register pair. Means after the execution of this instruction, the memory location 7030H will have the content 40H. That is the content of register B. Now again, since it is a copying, since this instruction only copies the content from one place to another and no arithmetic or logical operations are involved in this instruction, so the flags affected will be nil, no flags will get affected. Bytes, number of bytes, as I've told you, as I've given you an example, for example MOVM, B. Since as you can see from this instruction that it has no hexadecimal number mentioned in the instruction, so overall this instruction will be of 1 byte only. As I have told you, every instruction of 8085 microprocessor is minimum 1 byte, and that 1 byte represents the opcode. And now depending on whether there are hexadecimal number mentioned in the instruction or not, the instructions will be 2 byte, 3 byte accordingly. Since there is no hexadecimal number mentioned in the instruction, so this instruction will be of 1 byte, and that 1 byte represents the opcode of the instruction. Now, how many machine cycles will be used for the execution of this instruction? So, for example, MOVM, B. When you're going to store this instruction, as I have told you, when you write this instruction will get stored in the memory attached to the 8085 microprocessor, obviously. And how this instruction will get stored, since this instruction is of 1 byte, that is, it is having opcode only, so it will occupy only one memory location. So one memory location will be used for storing the opcode of this instruction. Now at the time of execution of this instruction, now one more thing, there might be a doubt in you people that if the instruction is of 1 byte, then only one machine cycle it will need, or if the instruction is of 2 byte, then it will need 2 machine cycle. No, this is wrong. Machine cycle has no relation with the number of bytes. For example, this instruction has 1 machine cycle, and that I'm repeating, I'm correcting myself. This instruction has 1 byte. This instruction is of 1 byte, and that 1 byte and it will use 1 byte memory location for its storage purpose. Now at the time of execution of this instruction, what will happen? Microprocessor will use first machine cycle for fetching the opcode of the instruction. Once the opcode gets fetched and decoded, microprocessor will come to know it needs to store the content of register B into the memory location which is specified by the HL register pair. Now both register B and HL register pair, all these registers are within the microprocessor. So microprocessor has the content of register B also. Microprocessor has the address where it is going to store the content of B. So it will use second machine cycle for storing the content of register B into the memory location which is specified by the HL register pair. So therefore this instruction will use two machine cycles, one for opcode fetch and the second machine cycle for writing the content of register B into the memory location. And the address of the memory location is in the HL register pair, which is in the microprocessor only. Now number of T states, obviously opcode fetch machine cycle will require 4 T states and memory write machine cycle requires 3 T states. I have already discussed about the T states, number of T states in the timing diagram only. So all total what will happen? 4 plus 3 is equal to 7. So it will record 7 T states. Now addressing mode, obviously the addressing mode is registered indirect addressing mode because here one of the location of the operand is indirectly specified by HL register pair. I have told you those instructions where the address of the operand is not directly given in the instruction and indirectly specified in the instruction, then those type of instructions will have registered indirect mode. So moving ahead with the next instruction, MOV RD, M. What does this instruction do? This instruction will copy the content of memory location and will store it into the destination register. For example, MOV B, M. So what does this instruction do? It will copy the content of memory location which is specified by HL register pair and it will store it into the register B. Let's take an example. Suppose the content of register B is 32H. Suppose the content of register B is 32H. Now content of HL register pair is 4060H and the memory that is attached with the 8085 microprocessor, in that memory the memory location 4060H has the content 20H. Now these are the things. Now after the execution of the instruction MOV B, M, at the time of execution of this instruction, what will happen? This instruction will store the content of memory location which is specified by HL register pair into the register B. So after execution of this instruction, what will happen? The register B will get stored with 20H. How? Because here the M is represented by 40, the memory location is 4060H as the content of HL register pair is 4060H. So in 4060H which data is stored? 20. So this 20 will get stored in the register B. Now again, the flags affected, since it falls under data transfer group and only copying operation is performed here, so no flags will get affected. Number of bytes, obviously this instruction has no hexadecimal number mentioned in the instruction. Example MOV B, M, you can see that no hexadecimal number is mentioned in the instruction, so this instruction is of 1 byte. So the number of instructions is 1 byte, and that is for opcode only. How many machine cycles will be used for the execution of this instruction? Now let's see. When you write this instruction, it will get stored in the memory. How it will get stored in the memory? Since this instruction is of 1 byte and it has opcode only, that 1 byte means the opcode only. So it will occupy only one memory location where the opcode of the instruction will get stored. And no hexadecimal number is mentioned along with the instruction. So no more memory locations will be used by the instruction. Now, at the time of execution of this instruction, what the microprocessor will do, it will first fetch the opcode from the memory. So, first machine cycle is used by the microprocessor for opcode fetch. Once the opcode gets fetched, it will decode. Microprocessor will decode the opcode, and after decoding the opcode, microprocessor will get to know that there is certain data in the memory location which it needs to get stored in the register, whatever register is mentioned in the instruction. For example, register B, if register B is mentioned in the instruction, then it will need to store that data into the register B. And which memory location? The memory location, the address is given by the HL register pair content. So HL register pair is already within the microprocessor, so the address is already with the microprocessor. So what it will do, the second machine cycle will be used for fetching that data, from the memory location which is specified by HL register pair. So second machine cycle will be used for memory read, for reading this data. The second machine cycle is memory read machine cycle, and once the data reaches the microprocessor will store that data in the register B and the instruction will get executed. So in this way, it needs only two machine cycles, one opcode fetch and one memory read machine cycle. T states, how many T states? You can see opcode fetch, it needs two machine cycles, opcode fetch and memory read machine cycle, and opcode fetch machine cycle has 4 T states and memory read machine cycle has 3 T states. So all total how many T states? 4 plus 3, 7 T states. So it will require only 7 T states. And what is the addressing mode? As I've already told you, whenever the address of the operand is indirectly specified in the instruction, then that type of instruction will have registered indirect addressing mode. So we'll continue with the rest of the instructions of data transfer group in my next video lecture. I'm ending this class here.